Much like a touch GUI event, the touch object event takes the functionality of a touch event and locks it to just a game object. It does something very specific only on this object. And I've set up 4 cubes in this scene. They're just hanging out doing nothing really. And each cube has a different set of rigging on it. So let's take a quick look at that, and then we'll see how it looks in action on an iPad. The touch object event has all the usual suspects that you should know well by now. Touch began, moved, stationary, ended, and canceled. So you can fire an event for each one of these. And it runs every frame and looks for these events. You can filter by finger ID again. I'm not going to do that in this example. I'm okay with any finger touching it. And it's attached to itself. Pick distance you can tune as well. I'm leaving it its default of 100. And I don't need to store any results in my example, but you certainly can, as in our previous examples. You can store the finger ID. When this is touched, you can store the hit point of where it's touched, and you can store the hit normal, which is really cool. You can store the normal of the object that's touched. It's pretty neat stuff with that if you get creative. On this one, I'm just looking for a touch began, meaning, in other words, if you poke this cube, then fire off an iTween shake. And this one, it's going to shake position and rotation. Just do like a 0.1 and a 2 in each of these for a couple of seconds. And when it's done, flow back into the idle state. On the second cube, same thing, looking for a touch began right here. And in this instance, I'm going to spin the cube and 2.5 on the y-axis. And that's it. It's just applying some force through add torque. And every time you touch it, it'll do this. So this one, you'll be able to kind of, tap, 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 and add a little more force the more you tap it. Pretty cool. Cube number 3, idle, looking for a touch began. And this one's a little funkier. You come into the wait for move. It's got another touch object event that looks for a move. Pretty neat. It looks for a move and an end and cancel action, just like we've done with touch events all along. And basically you touch it, that makes it active and gives it a finger ID. And then if you move, we filter by the finger ID. We look for the way out. In other words, did you pick up your finger or did you stop moving? And we shake. When you touch, nothing much is going to happen, but then when you move your finger, it's going to shake, which is pretty cool. When you stop moving, it'll stop shaking. That is another layer of kind of nested action. And here on cube 4, finally, we have another kind of dual thing. We look for a touch began. We flow into the spin state. So we're going to add torque on the X axis, just when you're touching it. But if you move, we're not going to do anything. We're gonna flow into this other state and not have anything happen. 4 different unique events that are going to happen there. And let me just stress this again. Each one of these touch object events is only going to respond if this one particular object is hit. Touch object event is doing behind the scenes all the dirty work for you. It's handling all the ray casts and all that kind of stuff to make sure you're only hitting this one object. Cube 1, 2, 3, 4, they each have different functionality. Let's take a look. Here's our 4 touch objects. And remember, touch object is only working on the particular object that it's attached to or that it's paying attention to. So here I'm touching the screen and nothing's happening. But if I touch on the object, then it triggers the action that's attached. In this case, I touch and hold nothing, but if I move, then I get that. And if I hold, still, if I move, it jiggles. You can have motion going on both of these at the same time because they're independent objects with independent touch object actions on them. You can even do them both at the same time for kind of a multi-touch thing. And of course, these function as well. That one gets some spin going as you tap it. This one adds spin as you hold it, but stops if you move. So we can spin this one up, get that one tapped, spinning, and there's all 4 of them moving at once. Pretty cool, but moving in the middle, tapping anywhere off of these objects does nothing. In this example, I've brought back the minigame that we've been using here a few times, and it still has the cube rigged up with the same motions we've already seen. But this time I've set up, as you can see in the right corner, 4 polygon objects, which I am using the touch object event on. There's one for each one for move up, down, left, and right. So this is very much like the GUI button setup that I showed you in an earlier example, except these aren't GUI textures, these are actual geometric objects. See, they're floating here in space up above the maze. I've got the maze object here, which you've seen before, and above it are these very simple polygonal objects. In fact, this is one object that I've just brought multiple instances into the scene of and rotated appropriately. They move just like any other geometric object in 3D space. One thing to note on the game, and I'm running it here with the arrow keys to move the cube around. These don't actually respond to click, they only respond to tap. But when the cube goes into a phase where it's not playable, like there, controls disappear. And then when the game's reset, they come back. And likewise, the same thing happens when you win the game. Move it over here and show you. The controls disappear again. So this keeps the player from trying to move the cube while it's in its win or its lose state. And it's important to clean up your UI and your GUI events and all kinds of things in the scene during phases like this. So kind of keep in mind you should rig things like that. Let me show you first the rigging. It's pretty easy. On each of these are just the 4 objects, like I said, floating in space, 4 copies of the same thing. And I haven't put any rigging on them directly. I went ahead and kept all of the intelligence in the control manager. And you've seen this before in the other examples. I've got touch object event right here. There's 4 of them, 1 for each of the arrow objects. And I've just added them. They're all named grid because that was the name of the object when it came in my modeling program. I modeled them in Silo 3D and I forgot to rename it. Anyway, they're labeled as the object arrow up, right, left, and down, but the 3D geometry itself is labeled grid, and that's why you see that name over and over. But I just drug those in to this. You could also get it from a variable if you wanted for the name. And I set them up just to respond to the move up, down, left, and right events. So that's all they're doing. It's a touch object, just like in the cubes we saw before. In this case, they're all looking at one object for one event, and then we do the standard move that we've already seen with the cube in previous examples. It's really that easy to just have this quick touch object event that will only respond to that button in that location. And you've seen all the other things we could add to it before, but just using a button, that's all we need. The real cool thing that's happening here is that I have a second camera that is overlaying this view of the game here that we've seen so far through this main camera right here. I've got a second camera right here, camera button. Let's zoom in and look at that. It's floating out here in space, and it's set up to look only at these objects and then render them over top of the other view. And let me show you how to set that up, because it is really cool and really handy, and not all that hard to achieve, really. Float the inspector. Whoops. Reselect. There we go. So you can see that I've got the draw distance is off. I think it's about 20 now. Yeah, the far distance is 20. It could easily be shorter, like there's 12. Just so long as it's far enough to reach that object, like there at 9, or here if I put it at, say, 5. Like back here it won't draw, and you can see in the camera preview that it's not rendering. So the trick here, you need to make sure that your draw distance actually comes far enough to get your object. So that's something I've seen people get tripped up on. Then the size you can set by when it's default, and I could have moved the camera back and got it in place. It's not all that important when you're not using textures, just so long as you get it sized the way you want. So for example, here as I make the camera larger, it's almost as if it's pulling back. So you can set this however you'd like. It turns out that 5 worked out really good for my needs right here. And I just tried to maximize it in the view. So here, of course, I've got it about as big as it can get vertically, and because the rendered field here is wider, I'm going to have more space on the sides. So let's move to the game view so I can show you how did it get over here, right? If it was really big in the camera, how did it end up like that? And how did it get overlaid? Well, the first thing, a camera by default is set up to a skybox setting for its clear flags. And basically the clear flag setting is determining how the camera is going to render a background. And on my second camera, camera buttons, I've set it to depth only, not skybox, but depth only. And the depth value is down here. I've set this to 20. You can have a really wide range of numbers. By default, the camera is -1. And the higher the number, the more on top the camera will draw. So a camera of 1 would draw behind a camera with a value of 2, which would draw behind the camera of a value of, say, 20. So you can use this to order things however you would like, draw order. I just gave this a big number, 20. Totally irrelevant as long as it's bigger than -1, since I only have 2. And I set it to depth only. If I had it on skybox, you can see it's drawing that, there's that typical kind of ugly blue that you get for default cameras in Unity. So depth only is a key there. I also have it set to orthographic and not projection. That's what gives me the size and the flat view. You could totally do this in perspective too if you wanted. I just chose orthographic. And the normalized view port rect, or rectangle, these are the 4 numbers that are going to totally make the magic happen here. So let's make sure we've got that selected. Zoom in. Oh, wait, one last thing I needed to show you. The objects themselves, these arrows, I have set a layer as buttons. And I've flagged each of these. Oh, do not change this, thanks. I've set them each as buttons. So that way the camera can identify when I come into the culling mask, which is right here below flags. I've chosen buttons and nothing else. You could choose everything and it would render everything on the scene. You could choose nothing, renders nothing. And you can toggle any of these off and on just by selecting them. So I selected it once, it's active. I select it again, it's not active. So I'm just going to pick buttons, and in the main camera, I make sure it switches to mixed to tell you that I have unchecked this, because when you add something new in a layer, it will automatically be added to your main camera. I don't need it to draw those buttons. And this is sort of irrelevant because the cameras aren't, like this camera is pointing down at this stuff, and it would never see these objects above, right? This camera down here, this one, would never be able to see these because it's out of its viewplane. And the same with this one, it would never see these things down here. But it's still good to clean these out so the camera's not looking for things and making passes that it doesn't need to. It knows it's only rendering this and it can move on. But you might have a situation where you have objects that are within the same field of view of different cameras. And that is how you specify right here with the culling mask that only certain things should render in certain cameras. Okay. Now let's make sure we've got our camera button selected. I'm going to move into this view. I'll float an inspector. And what I'd like to do is reset this to default. First of all, just to make sure that I can show you what this looks like. And let me pick. Okay, we've got orthographic. Got all that set up. Great, we're looking good. You see that now it's full screen, just like I had it in the camera preview. Make sure that's still selected there. Okay. If we float this and I select, instead of depth only, if I set this back to skybox, now I've got this color. Okay. So I've got a skybox color, and I'm going to leave this on for the example because it's easier for you to see what's going on with the shape of the camera if you can see the entire camera field. So I'm going to have it draw a blue skybox in the background until we get it positioned. If we start to adjust these, the X and the Y, okay, are the beginning position of the camera. And you can see if I move the number higher, it's moving away from the center point of 0 to the right. And if I make it a negative number, it's moving away to the left. So I'm actually moving the view of this camera when I do that. And the same thing with the Y, I'm moving it up or down. And it's trying to keep these objects on screen, which is why they're scaling for us. If I adjust these numbers, if I go above 1, nothing happens because this is a normalized set of data. And if you remember, we're talking about 0, 0 down here and 1, 1 up here. So we're only looking at 0 to 1 for both the X and the Y as a range. So if I go above 1, nothing's going to happen because there is no value above that. If I come down, I start to shrink the size of the camera. So set to 0.5, like this, it's half the X width, right? And if I set it to negative 0.25 or roughly, then it's about a quarter of the width of the screen. So it's working just like the earlier camera example we saw where we could reposition an object, the GUI texture object, off of, say, 0, 1 or 1, 1, and then use the inset to bring it back on screen. We're doing the same thing here by moving the size around. Same with the height. See, I can make it half its height by doing that, or whatever value of height I want that's below 0. The way to go about this is, let's say we bring both of these down, because we want this to be smaller as an overlay. And let me make this, let's say 0.3, I think is what I had the original camera. I'll bring this one down to 0.3. And there we've got a much smaller set of controls, and that's probably more the size I want them on the screen. All I've done is I've shrunk the camera, right? Instead of this point being at 1, 1, which would make it up here, and it would make the whole thing full screen, I've set it at 0.3, 0.3, which scales it down to here, makes it this size. And this is the point from which it's scaling. All right, now to move it to the other side, I just begin to adjust these numbers. Because remember, we're starting at 0. Okay, so 0, let's reset that, makes this bottom corner point attached to the 0, 0 of the other screen. Let's just move this over until I get it over into the range I want. I think that's around, let's make that 0.7. That looks nice and clean. And so now I've got it over there. And I'll bring this up a little bit. Not much. Like if you wanted it to float up here, you could have it wherever you wanted. So if you wanted to hang, say, some other button up here, or a meter or something, that's how you'd position it. But I want, oops, my mistake. Set that back to 0.3. I want this to be really low. I'm just going to set it to 0.1 actually. There we go. So that floats it a little bit, like 1/10 the way up. It floats it off the screen. That has positioned my controls right there. And if I change, of course, if you change the color, right, you're going to get the background color changing to what you want. But I am going to set this back to depth only, which means it won't draw a skybox. So it only renders these objects, which makes them appear to punch out over top as a transparency. And that is how you get a second camera to float a set of geometric controls over top of your original. One thing to point out before we move on and see this running on the iPad is there is a little flag called main camera right here in the tag, main camera, and it's on a camera by default, on your main camera. And every scene has one main camera. It doesn't mean it's the one that's being used most often. It's kind of a way to let some of this stuff behind the scenes, like we're doing these ray casts and such, this automatically uses the quote-unquote main camera to cast rays or do various calculations, knowing what point it's looking through. So what I did was this was set to main camera, and I set it to untagged, even though this is still named main camera. Don't let that trip you up. Because I don't want those things to occur from here. I want them to occur from this camera, which I then manually set to a main camera tag. That way, all of our little touch object events will work. If you try to run the touch object event through this camera, in other words, this camera right here that we're looking through is looking at these geometric objects and expecting a touch result from it. If you don't have this flagged as main camera, the touch object event simply won't work. So it's a very important thing to set up. And it doesn't matter which one is main camera, as long as you only have one camera in your scene labeled main camera. There you go. let's see how this runs on the iPad. Here's our controls set up with touch objects, and they respond just like the GUI textures that we set up for touch GUI, except these disappear completely instead of turn gray. Instead of swapping out for another object, I'm just completely making these not render, not be available, nothing at all. And that, of course, occurs when you go into, say, a lose condition or a win condition as well. So there, we've got a great example of just some geometry. Looks very crisp and clean. You can see there's no aliasing or anything like that because this is 3D geometry being rendered. You can put shaders on these, treat them the way you would any other piece of 3D geometry. This is a really quick touch object event that riffs on an earlier example we had in touch events. And I'm using this one polygon right here with a texture map on it. Actually, it's a cube, sorry. See, it's really thin there, but you could do it with one polygon too. And I've got it rigged up with a super simple FSM. Touch object event looks for touch began, fires off this state when you do touch it. And we're doing that old trick that I've shown you several times now in these series. We're going to use get touch info to get the XY of the touch. We're going to go down to the screen to world point. We're going to use that to figure out where in the world we touched based upon the screen coordinates. And we're going to set the position of the owner, which in this case is that polygon. And we're going to look for the end of a touch, filtering by finger 1 right here. So that'll let us out of this example if somebody stops touching. And because we're doing this every frame, right, and not just once, that means when we touch this object and move our finger around, this object is going to follow our finger. So let's take a look. Here our little cube is set up to be drug around, and because it's a touch object, just like all the other examples we've seen, nothing's going to happen if I touch anywhere else on the screen. But if I touch the object itself, I can start to move it around. So it's following me as I drag. That's pretty much it. Nice and easy. Touch it, drag it.